Now we're doing FreeCodeCamp, a legacy Python for everybody, relational databases, and SQLite. All right. So make sure we have our notes out. We got them right here, all the way to the bottom. I'm going to format this real quick using this little method. Throw this down here. Change that. Man, I got the wrong month one, but whatever. 10/06/24. All right, so now we're set on that. And let's go.
Hello, and welcome to our chapter on databases.
Hello. Okay, chapter 15. Let's do that. So let's start with that. Chapter 15, Relational Databases and SQLite. All right. So let's go down here under the date. Chapter 15. Relational Databases and SQLite. Okay. So let's take care of business.
We're going to learn a lot in this chapter. Learn a whole new programming language, SQL.
Oh,
and
yeah.
learn how to use that. So you're going to need a new piece of software to run all of the exercises that I'm going to do called SQLite Browser. We're using a database called SQLite. Go ahead and download this. You might have to pause and come back if you like.
I mean, might have to. We're definitely going to do that. That being said, we got to go over to the YouTube to go. Nope. Here's this right here. All right, let's open that in a new tab. What? All right.
Go to SQLiteBrowser.org and download it and install it.
Okay, so you're not going to tell us how or which one to pick or whatever. I think this might be the winner right here. The SQL, probably the 64-bit DLL times 64 SQLite, whatever. All right, so let's go grab that. All right, so we got this right there. Open. Let me see the full download. I don't have the history. I need to see the downloads. Right there. All right, so where do we want to put this? I guess we'll make a new folder on top of actually, let's see if it'll just do it for us. No, I don't think so. So let's go to the desktop, make SQLite, new folder, SQLite, boom. All right, so now we got that. Go in here and let's extract it to this place. Let's copy this path right here. And let's do that. Where are we? Right here? No, we're on downloads. Let's open this in a new window or whatever. 7-zip, extract files. Let's extract them to here. All right, and do it. So that's probably done already. Let's get rid of the downloads page. There they are. Woo. Okay. So now what? What's the next step, Chuck?
While you're doing that.
While I'm doing that. And while I'm doing that. All right. That's not, we're not going to, while we're doing anything, we're going to do this. All right. So here's this. We got this standard installer. I'm going to use that instead. Zip files. I don't like zip files as much as I like regular old standalone wizard, whatever they are. Let's go. Yeah, sure. Shortcuts. Sure. Let's find out where we're sending this. Oh, it doesn't say where we're sending it. Oh, here we go. What? Okay, I guess that's cool. Back. Let's actually program files DB browser for SQLite. That's fine. Program files is a good place for it. All right. So take your time. Oh, you got it. All right. Finished. So there we go. Now let's go watch this.
We'll talk a little bit about the history. So in the old days, 1960s, 1970s, I started doing computing in 1975.
Turns out
we didn't have a lot of storage. I mean, this is, 16 gigabytes right here. And, we didn't even have megabytes. I mean, the computer I had a few megabytes of stuff. So we didn't have a lot of disk drives. And so permanent storage was often sequential. And these tape drives that we had, tapes and tape drives were the scalable part of storage because you could just make more tapes and you could rack them up. And so that was our way of greatly increasing the storage of the computer. The problem they had is they were sequential. You read it advances, read it, advance, read and advance. Now, interestingly, we've been writing programs that do this, that everything we've written so far pretty much reads the whole file, reads the whole web page, reads this, everything we read it either a loop or read the whole thing. And that's because we have plenty of memory. But we're still reading sequentially. And so the way you would do this when you didn't have enough spinning storage or online storage is you'd use offline storage, but the trick would be that you would sort it. So let's imagine that you're a bank and you have a bunch of accounts, only a few of which are active on any day, and you have a tape that has, in account number order from low to high, the prior balance, last night's balance of every one of your bank accounts, and then you do all the transactions and you record how much money was taken in or out for each account number, and then you sort those transactions. And then what you do is what we call a sequential master update, and that is you would write a program that would read the first transaction and hold on to it. Say, okay, this is account 45. Then it would read the first account, like 1, and it would copy 1, and then it read 2, and read like 7, 8, 42, 43. Then it would read like 44, and then it would read 45, but it would change that and write the new 45. And read the next thing. And so this might be 60. And then it would read a bunch of stuff and copy a bunch of stuff. And then it would finally get to 60 and it would merge the add or subtract. And so the old balance ended up here and the new balance did here. And you had to only make one pass through the data. So it was super efficient. So we had all these mechanisms to sort. We used to do punch cards and have sorters and all these things. And then those things would run for hours. And if you watch old TV shows, these tapes are spinning and these things are running back and forth. These are simply reading and writing tapes. And that's how we did a lot of data processing because we could store far more on a tape drive than we could on a disk. And with racks of tape drives, we could scale the storage that our computers had. And so that's the way we did data processing, but it meant that the only way you knew what the old balance was it was the balance as of this morning before your bank started. You don't know what the balance was for the day, and that led to things like you can never you can never withdraw more than $100 a day or something like that because you don't know what the old balance was, or you might go withdraw $100 at a couple of different branches, and so they weren't able to look your stuff up right away. Now, it didn't take long until
That's bananas. That is absolutely crazy. But it's the beginnings of this. All right, so let's write this down somehow. I don't know what's going on here, though. So this was what it used to be. Then you would give it like punch cards or data. And then it would change the data based on what got changed. Turns out. All right, so that's what's going on there. I don't think we need to write that down because that's not how we do business. But maybe we should because just because we don't do business like this doesn't mean that's not how it used to be. Reflections of. All right, the way banking used to be. All right, let's do it. So, old. Okay, let's say sequential master update in the 70s. Sequential master updates in the 70s. with 70s with tape drives. Tape drives. Right? We would do something like this. We would say old sorted data on tapes on a tape. Let's see this. And then let's do this. Merge. That's not how we do business. And then new sorted data on tape. On tape. We could go, hopefully you know what magnetic tape is. And I don't have to talk about that. I don't want to, honestly. It's such old technology. I used to have a tape deck in my car when I was a young man. All right. One more of these will be fine. And then we'll say right here, transactions sorted. Let's say sorted transactions. Sorted transactions. All right. Sorted new data. Sorted transactions to be added. To be added. There we go. All right, so there's that. Let's go to the next part of the video. All right, where are we? There. Boom. Random access memory.
Able to look your stuff up right away. Now, it didn't take long until the disk drives got better and better and better, and you could store the entire accounts, all the accounts and their current balances on computers.
This was hot technology. At one point, this was very, very hot technology. Very new hotness. Ooh, that looks like a trip down memory lane right there. Pardon me. Let's throw this random access in here. All right, so random access. When we can randomly access, hold on. When we can randomly access data. How is this learning? What is this? Whatever. He's doing the best he can. How can we lay out data to be most efficient? Sorting might not be the best idea. Sorting might not be the best idea. Okay, well, maybe we'll go into this.
And then the problem becomes is what happens if sort of in the middle of the afternoon you want to update a balance? Well,
true.
Do you want to read all your data and then write a brand new one? And say that takes like 10 minutes. That means for that 10 minutes, only one person can be updating their bank balance.
True.
And so because we could randomly access this data, we didn't have to read it all sequentially. The trick is how do you spread the data out? And then how do you make it so you can change a balance? This is, of course, second nature today, but how do you make it so you change the balance here without changing the balance there? And you can have multiple people going simultaneously to these things and make sure that you can't say to withdraw money at two different locations simultaneously and somehow have your bank balance get corrupted by that.
True.
So there's a lot of debate on how to do that. And in early days, we just did sequential master update. But increasingly, we want to...
Hey, good morning, Richard. How you doing? Just another Sunday fun day.
To make better use of the random nature of our computers and our storage. And so that's what led to databases. Databases are the science of how you make use of rotating random access data, permanent data, in a way that allows you to read, modify, and update that simultaneously from many different locations and yet keep the data completely consistent. And so this led to a...
All right, so let's do this before he starts talking some more. All right, so relational databases. Let's do that. Relational databases. Okay. Relational databases. Model data by storing rows and columns in tables, right? Just like a database, right? Anyway, the power of the relational database lies in its ability to efficiently retrieve data. Okay, let's drop this down. We're going to drop this one down first. And we'll drop this one down also. To retrieve data from those tables, and in particular where there are multiple tables and the relationships between those tables involved in the query. Okay, so let's read this again. Period. So relational databases model data by storing rows and columns in tables. Yes, just like Excel, right? The power of the relational database lies in its ability to efficiently retrieve data from those tables, and in particular where there are multiple tables and the relationships between those tables involved in the query. All right. So it's been, what, 25 years since I've touched Excel. You know, I don't like databases myself, but I did take a class on this, and that's where this stuff is learned. But hopefully we'll go into this in useful depth. We'll see how we can do that with Python. Let's go.
A study of a thing called relational databases. And there's relational databases are not the only databases that happened. We had many other kinds of databases, and there was a debate. And I remember in the 70s and the 80s, there was folks that says, oh, no, there you could do index sequential. That's the way to do it. And relational databases weren't all that popular the first time that I saw them. I didn't like relational databases. But relational databases had an inherent advantage because they were based on some really powerful mathematics. And the interesting thing is early on, the relational databases were slower, but eventually they figured out how to sort of bring all the cleverness to bear to make relational databases fast. And so relational databases are a pretty advanced technology, and there are companies like Oracle that are very, very wealthy, and their primary product for many, many years was nothing more than a clever database product, a clever piece of software that was really good at solving this problem. And that's how important this problem was to computing.
True. Okay, I'm just saying true because we got to get to typing. All right. So terminology, let's do it. Terminology. Let's do this. Is that how that word's spelled? Terminology. Yeah, it is. It's a stupid looking word once you look at it. All right, so we got database. Let's do this as usual. All right. So it contains many tables. Okay. What a definition. Contains Many tables. I believe it. Okay. Relation or table. Or table. Contains tuples and attributes. All right. So we got a tuple or a row. Tuple, also known as, or row, also known as a row. Okay. So it's a set of fields that generally represents an object, all right? Like a person or a music track. Makes sense. Attribute, also column or field, also column or field. All right. One of possibly many elements of data corresponding to the object represented by the row or the tuple, right? Anyway, so let's read these again without the pauses. So database contains many data tables. Okay. Relation or table. What is this terminology? Okay. Relation or table. So the table and the relation are the same thing, I guess. So this contains tuples and attributes. These two things, all right? So the tuples are the rows, a set of fields that generally represent an object like a person or a music track. Row. Columns are up and down. Rows are side to side. Okay. So the people would be here. Attribute. And the attributes would be up here. Like Jimmy attribute. Attribute A, he's a man. He's from wherever he lives and blah, blah, blah. And those are the attributes. All right. Makes sense. Let's go.
If you read about databases, you're going to see two sets of terminology. One set of terminology comes from the mathematical background and has to do with the underlying math. Things like relations, tuples, and attributes. That's kind of like the fancy math version of it. And programmers kind of think of them as rows and columns inside of a table. And so if you look at sort of fancy theory, you'll...
Oh, let's write down this stuff that Wikipedia said. So that's the relation between the tuple and the attribute. Okay. Makes sense. I'm never going to call this tuple because the word couple has an O in it, right? So why wouldn't tuple? Is there a proper thing about a C? I don't believe there is. I went to a lot of English classes. I don't believe there is. I believe that these guys are just doing whatever they want. All right, so let's write this down. This is actually pretty important. So a relation, or it looks important, is defined as a set of tuples that have the same attributes. A tuple usually represents an object and information about that object. Let me put a period here. All right. So now objects. Does this have a title? Or is it just a table without a title? Yeah, it's just a table without a title. Okay. Objects are typically Physical objects. Look, I haven't done, like I said it a few minutes ago, I haven't done databases since high school. But I know for a fact, and I'm sure you know this too, for graphs and tables, you got to have titles, right? Because whatever, but you know, it's too early in the week to be getting on Chuck for this stuff today. Objects are typically physical objects or concepts. What else do we got? A relation is usually described as a table. True. Which is organized into rows and columns. True. All the data referenced by an attribute are in the same domain and conform to the same constraints. That's interesting. Like, the more that this guy talks about the old days, the more, like, because, like, this just seems like the way, right? But the thing is, according to him, this is just a way. This is just a way of doing business. There are plenty of other ways of doing business. You know what I'm saying? And from what he just said, this was probably invented in the 70s, right? So it's almost only 50 years old. Like, compared to like addition and subtraction, you know, those are also things that had to have been invented at some point. This is relatively young, right? So that's very interesting. It's very interesting, in my opinion. All right, regardless of interesting or not, let's go back to the video.
You'll see words that look like this, and they're just full of this in the connection. Now, all this
what
is
are you talking about?
Inside of a table. And so if you look at sort of fancy theory, you'll see words that look like this, and they're just full of this in the connection. Now, all this is important and true, and if you really want to get good, you sort of begin to understand the nature that we model data at connections rather than at sort of intersection points, rather than just modeling data as a
well, yeah, that's how you would do it. I mean, you have to go to the intersection of the tuple and the attribute of Jimmy and the attribute height, you know, whatever his height is, you know. What's Jimmy's height? What is Jimmy's height? It's going to be X centimeters, inches, whatever you want, you know. That's how that works. It seems like, honestly, it seems like second nature, but this guy is literally talking to us as if this is not, you know, this could be something different. Honestly, that's what I'm hearing. That's what I'm hearing when this guy's talking while he's digging in his ear. Let's go.
Flat file the way you do.
You know, that's why I don't like to show my face, because I can dig in my ear all day long and you'll never even know it. Just kidding. I got headphones on. Let's go.
But for now, we're going to, as programmers, think of this as just like, oh, it's like a super fast spreadsheet. The super fast part is the math. For us, the rows, columns, and tables are spreadsheets. So think in a spreadsheet of sheets, sheet, and that's like a table, a named thing like tracks or albums, artists or genres. And then there is rows, and each row has a different kind of data. And then there's columns, and we sort of specialize the first column in many spreadsheets to say what's in there. This is not really the data. This is like metadata. It's like the title's in this first column. That's not really the data, and the data starts here. And we have different kinds of data like strings and numbers, et cetera, for each of the rows. And literally, you can get away with this as sort of about 80% of databases is just a really super cool spreadsheet. But under the covers, it is far more powerful than that.
I believe it.
One of the early...
All right, let's do this. SQL. All right, SQL. This is important. I've heard this the entire time, and I knew it was databases, but I've never once stepped foot into this realm. All right, so structured query language SQL is the language we use to issue commands to the database. Let's drop this down. True. What we can do with this is we can create tables, retrieve data, insert data, and delete data. Delete data. Move data around and all kinds of stuff, But that would be inserting and deleting. All right, so let's go.
Early arguments that happened was, again, what the programming model for this was. And a lot of folks wanted a programming model that reflected how the data was actually stored. The notion of structured query language came about in a way to express what you wanted to happen and allow that to be sort of a very abstract expression. Select all records that meet this criteria, not read, 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 read. And so structured query language is not a procedural language. It is a imperative language where you're simply saying what you want, and then somebody writes the loop. The database actually does the loop, but it's a way for you to avoid actually writing the loop. Now that turns out to be the power of databases, because the cleverness in how to write the loop is a way that you would probably never figure out how to be most supremely optimal when it comes to writing the loop.
You're right, because I just literally just got into this. But that being said, I haven't been able to focus on this. I've been looking at this Internet Gopher thing, World Tour 93, and I'm just looking at it and I'm like, that's a really well taken care of shirt if that's actually from 1993, but who knows. All right, we're going to go back to the beginning of this because I am so lost what he's talking about. All right.
Programming model for this was, and a lot of folks wanted a programming model that reflected how the data was actually stored. A lot of that is percent of databases.
I got to do it again.
Really
I'm sorry.
Cool spreadsheet, but under the covers, it is far more powerful than that. So one of the early arguments that happened was, again, what the programming model for this was, and a lot of folks wanted a programming model that reflected how the data was actually stored. The notion of structured query language came about in a way to express what you wanted to happen and allow that to be sort of a very abstract expression. Select all records that meet this criteria, not read, 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 read. And so structured query language is not a procedural language. It is a imperative language where you're simply saying what you want, and then somebody writes the loop. The database actually does the loop, but it's a way for you to avoid actually writing the loop. Now that turns out to be the power of databases, because the cleverness in how to write the loop is a way that you would probably never figure out how to be most supremely optimal when it comes to writing the loop, as you'll see toward the end of joining many tables together and selecting and throwing array and getting down to a count or whatever. Someone has figured out how to do that really, really well. So the idea is you would express, we're going to create some data, we're going to retrieve some data, we're going to insert and delete it. Create, read, CRUD, C-R-U-D.
That looks like CRID.
Create, read, update, and delete.
So it could have been anything, but they were like, I'm going to make it CRUD. CRID. It could have been anything that they had to do like that.
CRUD. And so that's what this does. It's a language that does this very simply. Now the applications that we're going to use...
Oh, just what I wanted to see, a flowchart. Just kidding. I hate these. So input files, Python programs. Pythagorean theorem. Okay, Python programs. Okay. SQL database file. SQLite Browser. What? What? All right, let's watch him talk about it.
This 4 are more of a data analysis application. We've been doing data analysis through the whole course. And the kinds of things that we'll see in the remaining chapters is we'll take some raw data file. These might actually come across the network. And we'll write some Python programs to play with that data, parse it, clean it up, make sense of it, and then write it into
True.
a database. And this might be a slow process, or this might be really nasty, and this might be a way to have very clean data. And then we'll write another Python program to sort of read through it, and it's all efficient and pretty. And then we can produce files, and maybe we'll visualize it or do further analysis in R, Excel, or a JavaScript visualization framework.
Okay, that
and
makes more
so
sense.
in this situation, you will be the person who is both sort of writing the programs, database administrator, and you can, using SQLite Browser, play and look at the database kind of in a raw way. And the first part of this, we are mostly going to be using SQLite Browser just to talk straight to a database. Later, we'll write Python programs that read and write data and visualize the data. So this is what we're going to do first.
I believe it.
And then second, we're going to do this part right here. That's the second thing we're going to do.
Uh-huh. Okay. Okay, so we would get some crazy looking files or data, whatever. We would write the program to parse the crazy looking files into something that we can actually deal with. And that's going to be stored here. And then we're going to write another program to look through the data that we created. So one program to clean it, one program to search it, and then I don't know what this is, but we'll see. All right. Web applications with databases. Let's get on this before we get thrown all those words and confused. All right. So web applications with databases. So application developer, that's us. Application developer builds the logic for the application. The look and feel of it, monitors the app for problems. Okay. I guess this is like a program that we're going to write or something. But whatever. Let's go to the next part. Database administrator. Database administrator. So this is going to monitors, and it monitors and adjusts the database as the program runs in production. Okay. Often both people, so these are people. Okay. Often both people participate in the building of the data model. Okay. What's up with this? Why is my brand new computer stuttering so bad? I hope it didn't stutter video recording. Anyway, whatever. Let's go.
Now, another really common use of applications and something that if you continue learning more about programming is that you will want to write an online application like Amazon or a company or Twitter that's got a website and it stores dynamic data in databases. And so the picture for that is similar but different than the picture we're going to start out with. And so the way this uses...
Okay, let's look at this. Database, data server. Where are we? The end user. That would be the regular person. Application software. That would be Facebook, I guess. Database, data server. That's what serves Facebook, I guess. The developer is us. Doing business as. Is that what DBA is? Database. All right, let's see.
Usually works is that you, the end user, uses a web browser, talks to the application, and the developer writes the application software, and that application software stores its data in a database, and inside that database we talk to the database using SQL, and all the data is actually stored here, and the magic happens. The data server is that database software that's so precious and valuable. And then there's another person, often called the database administrator, who has access to the direct access to the data. And these roles in medium and large project are kept separate, mostly because the production, while it's running and live, the developer leaves the data alone and works on, say, the next version of the software. And then the developer has a test version of the application that they run on their computer where they're doing all that stuff. And so this database administrator is a role in a large project where we have to run production and keep production careful, keep production in good shape. So the database administrator...
Okay, let's write this down. This is what a database administrator does. These are the jobs of people. All right. Database administrator. Database administrator. All right, let's write this down. So what's this say? A database administrator, or the DBA, is a, whoop, that's not how you do it, is a person responsible for the design. Where are we going down there? Right here. For the design, implementation, maintenance, and repair of an organization's database. The role includes the development and design of database strategies. Okay. Monitoring and improving database performance and capacity, and planning for future expansion requirements. Honestly, when I see this stuff, when I see stuff like this, I'm just like, oh man, how am I supposed to do this? There's so many roles. You have to, it's like you got to have a team. They may also plan, coordinate, and implement security measures to safeguard the database. Measures to safeguard the database. Is that how it is? Or didn't they like create security specialists since then? And now they're two different jobs? I don't know. Let's see.
Administrator has this responsibility for the production aspects of the data, and you may be working in a situation where that you're not actually controlling the data. The database server's on different computers. You have a little special access, and you write programs to sort of read the data. And so the database administrator is the person who is asked by the organization to administer that data. The data that we...
So in depth. All right, let's go. Database model. Database model. Okay. So a database model or a database schema is the structure or format of a database described in a formal language, supported by the database management system. Okay. there's other words for this. Let's see. In other words, a database model is the application of a data model when used in conjunction with a database management system. You don't have any other words? Like some simpler words than that? Ah, just kidding. That's the second time I've used this joke in the past 3 months. Okay, let's read it again, but this time let's understand it. So a database model or database schema is the structure or format of a database, described in a formal language supported by the database management system. What formal language are you talking about? Like English or like C++ and SQL? I don't know. Probably the SQL. I don't know, honestly, which formal language he's talking about. Is that like, I don't know. Anyway, in other words, a database model is the application of a data model when used in conjunction with a database management system. So it's the application of a data model used in conjunction with a database management system. Okay. Oh man. It's that strong learning yawn. Oh, so much learning. I think from what I've read online, and I don't know if this is true, some people say that yawns are like the body automatically cooling off the head or something like that. I don't know. But I don't know. I don't know what it is. I don't know what a yawn is. We could go chat GPT it, but we're in the middle of database models. Let's go.
We develop, and we'll do this in the second part of these lectures, conforms to a data model. That's the metadata. Is this an integer? Is this a string? You know, how many columns is this? And the data model turns out to be very, very important. And there's a lot of science to building an effective data model that leads to really good performance. And it's a collaborative activity between the application developers and the database administrator to make it so it's efficient, runs in production, et cetera, et cetera, et cetera. There's a lot of...
All right. When he said that collab thing, yeah. The thing about it is, like, when we're over here learning by ourselves and all this stuff, you know, I don't know about you, but I kind of lean more towards the direction of do it myself, you know, a little DIY action. But the thing is, like he's saying, it's probably better if there's a lot of people on a team or a certain number of people on a team, who knows, taking care of, you know, everybody taking care of their own portion of the project. And I'm pretty sure that's where college comes in, right? When you go to like a university or a college or something like that, you're going to be paired up with your buddies or paired up with strangers or paired up with people you hate. You know, it all depends on who you're getting paired with. It really doesn't matter who it is, but you're going to have group projects, right? And that's one thing we can't get while we're learning alone is these group projects. You know, we could get as good as we can at everything. We could get good at everything. But the thing is, it's proven synergy works more than just individual effort, right? Because if Jimmy is taking care of this thing and then Johnny's taking care of that thing, both at the same time, it's a lot better than you taking care of that thing and then taking care of the other thing, because they're both getting done at the same time. So clearly synergy is the practice, is the way. But whatever, you know. And to clear that up, if we're working solo, the whole synergy problem, we could probably write programs that took care of task A and task B at the same time. And then large language models and whatever. So we'll see what happens, but let's type this stuff down first. This is just my speculations and conjecture. There's no proof to or if there is proof, I don't know where it is. Common database systems. All right, let's do this. Also, I don't even know if what I said made sense in the long run because I'm not watching what I'm saying. All right, so 3 major database management systems in wide use. All right, so we've got Oracle, which I've heard of. It's a large commercial enterprise -scale, and it's very, very tweakable, adjustable, updatable, very it's very tweakable. I don't like that word. It's very customizable. Okay. We've also got MySQL. Which is simpler but very fast and scalable. It's also commercial open source. Okay. And then we've got SQL Server, which is what I've heard of a lot. Very nice from Microsoft. And also Access. So is Microsoft Access, was that like not owned by Microsoft to begin with? Is that what that's saying? Many other smaller projects, free and open source. We've got HSQL, SQLite, Postgres, ... etc. Let's just put etc. All right, let's go.
Products out there that you may encounter. We're going to be using SQLite. SQLite's a little tiny database server, and it's built into so many things, and that's why we like it. But if you're going to work at a large organization, you could easily run into Oracle, which is the #1 commercial product. Microsoft has a thing called SQL Server, which is a commercial product, and it's also very popular and very effective. The more popular open source, there's things called Postgres, there's MySQL, and MySQL recently was sort of bought by Oracle, and there is a copy of that called MariaDB that doesn't belong to Oracle, MariaDB. And so most of the SQL that we're going to learn is common across these database systems because SQL is a standard, but then there are parts that weren't part of the original standard where each database vendor has done things a little bit different. But there is a core common subset that does the basic create, read, update, and delete operations. So SQLite is a very popular. You probably have it in your cell phone 10, 12 times. Your web browser has a database engine in it. Your car has a few databases in it. And so SQLite is what's called an embedded database system. Python comes built in with it. You just import SQLite 3 and away you go. And so it's a very, very popular because it's free, it's open source, and it is such a tiny little piece of software that you just include it in other pieces of software and use it to solve the data management problems of those pieces of software. Like your browser might use SQLite to store your bookmarks. Now you think, oh, there's only how many bookmarks can you have? But what if you need it to be fast? And what if there's like people that have 10,000 bookmarks? There probably are.
10,000?
Fast, you want to be able to search, and so you get all that by using a database like SQLite. And so again, we're going.
That is a bananas number, 10,000 databases, 10,000 bookmarks. But, you know, crazier things have happened. SQLite Browser. All right, let's do that. SQLite Browser. All right. Sometimes I see browser and I see the word Bowser. SQLite is a very popular database. It's free, fast, and small. Okay. SQLite Browser allows us to directly manipulate SQLite files. We go get it at SQLite browser.org. And then what else? SQLite is embedded in Python. Okay, and a number of other languages. We've only got 50 seconds left in this video. I wonder if we're going to get another slide out of it. I doubt it. Let's go.
I'm going to encourage you to download the SQLite browser.
We did.
So you can follow along with what we're going to do coming up next. And so here is the SQLite browser. Here's what it looks like. And it's just a desktop application. And coming up next, we'll start playing with this desktop application and see how it works.
Okie dokie, schmoky. So there's that. And there was actually another slide. We just didn't need to write down. All right, so there's that. So we already went here and we already went here. So we're going to go to SQLite usage in the next video. And then we'll go hit the question up and finish the rest of the stuff. All right, so there's that. So now we're on to SQLite usage. And we'll see you next time.